Good morning, everyone. This is Shravani, and I'm going to speak about operating system of Unit 2. And the topics are like what is process, process concepts, and operations on a process. So, coming to this next slide. So, first of all, the process. So, basically, what is a process? A process is basically a program which is in execution. The execution of a process must progress in a sequential fashion. A process is defined as an entity which represents the basic unit of work to be implemented in the system. Like to put in the simple terms, like we write our computer programs in a text file and we execute this program, it becomes a process which performs all the tasks mentioned in the program. So when the program is loaded into the memory and it becomes a process. So it can be divided into 4 sections. Like until the program is loaded into the memory, the program will be stored in the secondary memory. Once the program is loaded and once we run the program, so then the program will be loaded into the memory. Then the some memory will be allocated to that program. So the program which is in execution or the program under the execution is called as a process. And now we see how the process structure will be there. So as shown in the diagram, so this is the basic structure of the process. So first it contains like code, or you can say it as text or code, both are the same. Next is data. Next it contains heap. Next it contains a stack. So whenever as we discussed, like a program should be loaded into the memory, then it becomes a process, right? So once when the program is loaded into the memory, what happens? It can be divided, that program will be divided into 4 sections. So first section, it will be divided as data or text. Next, it will be divided as, code or text. Next part of section is like data. Third section is of heap, and fourth is of stack. And this diagram shows it is a layout of a process. Like inside the process, this is one layout. So this is the layout. And next, so now we'll discuss one after the another. So what is actual the data? What is actual the code? I'll start from the text or code. So what is this code? The code is nothing but it is a program. So once the program is compiled, so once we write the program, then we'll start compiling. So once after the program is compiled, it will be converted into object file. So that is, if for example, if you have written the program called as program1.c, and after compilation it will be converted into program1.object file. So this object file will be stored in the code part or text part. Next, speaking about this data part, here this data part, it stores the, like in the program, if your program contains any of the static or global variables, the static and global variables will be stored in this data part. So coming to the what are the static variables? The static variables are the variables which are declared at the compile time and they remain until the complete execution of the program or complete run of the program. Here values which are assigned to the static variables are preserved. And coming to the dynamic or global variables, so the global variables has a global scope all over the program, and as we all know that it can be accessed anywhere in the program, anywhere throughout the program. So this is all about data. So next we are discussing about the heap. So here is a heap part. So we'll discuss what is heap. Heap, like it is free space which is available in the memory, and this heap mainly it is used for dynamic allocation. So dynamic allocation into this, the allocation of the memory at the runtime is called as the dynamic memory allocation. So with the help of the heap, the dynamic allocation is done in the heap section. Okay, and next is stack. As we all know that stack is like first in first out or last in first out. But actually here what stack stores is, yes, it is the order is like last in first out or first in last out. The order is the, I mean, we all know that stack is first in last out or last in first out, LIFO. But here the stack, I mean, and also it will store some local variables. It stores some local variables which like declared, which we are declared in the program. Okay, and it also stores some methods or function parameters and return addresses. It also stores and some recursive calls, recursion code which are handled in the stack as well. Well, this is all about the process, the concept of the process. Once after loading, so what happens? This is it. And next, moving on to the next slide. So we'll see the states of the process. So basically, there are 5 states of a process. So first one is new, second is ready, running, waiting, and then terminated. So these are the basic 5 states of any of the process. Okay, first of all, coming to the new. So this new process, what is a new process? It is a program, or it has been like, it is a program when it will be created, or we can say that it has been created. In the simple words I want to explain, it is a program which is in secondary memory that is put in the main memory. So this is called as a new state. Means the program which is present in the secondary memory. So for execution, if that the program is taken out and it is put in the main memory, means then the process we'll say that the process is in new state. Next, coming to this ready state. So this ready state defines, so if the process is in ready state, so it defines the process is created and the process is ready to run. Okay, and next, if any of the process is in running state, it defines the process it is executing already, it has started executing the program. And next, coming to the wait stage. Like if you want to define any of the waiting state, like the process moves into the waiting state if it needs to wait for a resource, such as waiting for user input or waiting for a file to become available. So if it is waiting for any of these, so the process will be entering into the waiting stage. And again, so once the resource is found, once it gets the resource, then again it will go into the ready state, and again it will start into the running state. And finally it is terminated state. So once this terminated state, once the process execution is finished, so the program execution is completed, then it will enter into this terminated state. Means here what happens, so it is the process or the program is removed from the main memory and again it has been put into the secondary memory. So this is the terminated state. And next, like we are going to discuss on operations on process. So there are many operations that can be performed on the process. So some of the main common operations are like creating a process. First we need to create a process. Next is process preemption, process blocking, and process termination. First of all, going to the process creation. So in the unit 1 we have discussed about system calls. So if you want to create a process, if you want to create any of the process, so it generates the fork system call. So it generates a fork system call. With the help of this fork system call, the process creation will be done. And this diagram shows, I think you can see the diagram. And on this creation, what happens is like, so first of all, when the user requests for the process creation, so first of all, what happens, the user will request to create the process, means he will compile and run the program. Then the system will initialize the process and then it starts executing a process by creating the fork. It starts executing the process and then it initializes the job to that particular process. As we discussed, like a process is created by using the fork system call. So this creating process is called as parent process, and it can create a process and the created process, and this parent process can create one more process that is called as a child process. So the creating process is called as parent process and the created process is called as child process. I hope you all understood. So but here a child process can have only one parent, but a parent process may have many children. Okay, both the parent and child process have the same memory image. Same memory image in this is like IDs will be different, but what all the images, what all the instances this process will be present, parent ID will be, parent process will be having the same type of image will be present in the child process also. Next, like, but they'll be having the different address spaces. So different ID or unique ID will be present for different, will be given for for the parent process and the child process as well. So this is about the operations on process. So as shown in the diagram, like, so once the process can be created using the fork, and once the process is created, it can create the child process also, and it can, the parent process and child process can be executed, and until the sometimes until the child process executes and it gives the output, the parent process will be in waiting stage. Once the child process completes the execution, then parent process will start the execution. And once the both child process execution is completed, so child process and parent process, so first initially child process will be terminated or exit, and then parent process will be terminated. Okay, these are the topics, and thank you, and we'll be continuing in the next class.